Alright, hello, welcome back to A Software Engineer Plays. We're back in Human Resource Machine today. And I've been really thinking about level 40 here, the Prime Factory, and been really wanting to turn on a couple of these lights, so we're going to try and get one of these lights on in this episode. We'll jump right in, Prime Factory. Last time we did kind of an iterative approach where we took the number in question and we just broke it down. We divided it out we started with 2, saw if it was divisible by 2. If it was, we divided all the way out by 2, then we would increase the divisor until we got all of the prime factors out of the way. So you can see here we went 16 down to 8. 8 was divisible by 2, so we continued there. And then 4 was divisible by 2, so the prime factorization of 16 is 2 times 2 times 2. But in the research that I've done, I found a couple of other approaches to do this, which involve a lot of pre-computation. So basically what that means is we're going to want to pre-compute the smallest prime numbers for every number from 2 up to 20. You can see, I mean, this iterative solution was not the fastest, but if we start fresh here, what I want to do, clear out all these labels, and basically, get rid of these here. We'll keep 0 around, but you can see that we've got enough space in memory here. We go from 0 all the way up to 24, so we've got 25 squares. And we know that the input numbers are, they go from 2 all the way up to 20, those numbers there. So we have enough space in memory to compute all of the numbers from 2 all the way to 20, compute their smallest prime numbers. And I found some algorithms online which use this approach to quickly and compute the prime factorization of a number. Of course, we are limited by the memory that we have here, and a real computer would be limited by the memory as well, but since we have enough space, I kind of drew it out in Notepad here. So all the numbers from 2 to 20 there, their smallest prime factor is calculated. And then an example of the algorithm, you can see down here. So 20, the smallest prime is 2, so then we divide by that smallest prime to get 10. The smallest prime of 10 is 2, so we divide by that to get 5, and the smallest prime of 5 is 5. So when we divide that out, we end up with a 1, and 1 is our end case. So we do the example there for 20, and then we have another example for 18. You can see 18 goes to 2, 18 divided by 2 is 9, 9 goes to 3, 9 divided by 3 is 3, 3 to 3, 3 divided by 3 is 1. So we have all of these pre-computed. So now we have to go through the super fun process of getting it set up in memory here. And we're going to make use of the indirect feature of the game. So we're going to actually just use starting at 2, so we're going to be able to jump indirect to 2 to get its smallest prime factor. So we're going to get everything set up here. We're going to have a record of the number 1, because that's our end case. And we're going to run all the way up to 20. So I'm going to go ahead and fast forward in the edit through this, but I'm getting all of the prime numbers set up here. Fast forwarding through. You can see it's a tedious process, but we'd only have to do this once at the outset of the problem, so every number after the first we'll be able to make use of these numbers, so we're not going to incur this cycle time on every number. If we had to do the setup every time, then this would be a woefully slow solution, but sometimes it can actually be faster to do a lot of setup beforehand. Alright, so let's just run through this here, make sure we get everything set up properly. 1, 2, 3, 2, 5, 2, 7, 2, 3, 2, 11, 2, 13, 2, 5, 2, 17, 2, 19, and 2. Okay, so with that, yeah, we're not outputting anything yet, so it's not working, but we do have our numbers set up. We'll just run through it here and check again. And I'm recording this voiceover after the fact, and I did actually make an error on number 15 there. That should have been a 3, but I initially had it as a 5. But I'll fix that later on. Anyway, we've got our numbers set up here, so now what we want to do is go ahead and get our inbox set up, and then all of our variables to handle working with the numbers. So we go ahead and inbox. We do have enough space in memory, as you can see, to handle all of our variables, so we are going to name slot 0 here our working spot. We're going to inbox into slot 0. So we're going to copy to work there. Good. And then we want to set up our actual division part of the program. Now, we've done division in Human Resource Machine before, and we know that to do division in this simplified assembly language, we have to subtract a bunch of times until we get down to 0. So we're going to start by doing that. But first we need to get our divisor, or our smallest prime. So we're using the indirect copy there. You can see copy from work indirect, because work in this case would be 7, so we're going to end up copying from 7 indirect, which is 7, and placing that in the divisor field. So now we can start dividing our input number 7 by our divisor 7, but we can also output that number first, because we know that we're always starting with the smallest possible prime, so we can always output our first number. Okay, so now we're going to start doing our division, and to do that we want to copy from work and start subtracting the divisor. So we'll get that, copy from work, subtract divisor, and then we want to keep track of how many times we're doing this subtraction. But let's go ahead and put an end case in here first. If the work gets to 0, that means we're done. Now we can bump up our count, so let's get that in there. So that'll keep track of how many times we've done the subtraction, which is essentially all the division operator is. Alright, so we'll jump up to the start of the loop first, just to make sure our loop is working properly. And we want to copy that back to work. Now we can put our bump in. There we go, so we'll bump up the count. And that should now work. So let's go ahead and test that. Skip through this really quickly. Alright, so we're getting 18, so we're going to pick up a 2, and we will outbox that right away. Now we will start doing our division. So 18, start subtracting there, and you'll notice we have not initialized our count variable, so we'll go ahead and initialize that, and instead of doing it up at the top of the program here, we want to do that near the entry point, because we're going to need to reset our count variable for every new number we inbox. So let's move these down here. Alright, that's good. We're going to name this the entry point, just so I can keep track of everything. Alright, so now let us see what we've got here. We've got our loop, and let's test it out. Stepping through here, bring a 6 in. 6's smallest prime divisor is 2, so we'll outbox that and then divide by 2. Do our subtraction. So yeah, we should end up with a 3 in the count, but our jump if 0 is in the wrong place here because it's reading off the count variable. So we actually want to do that off the work variable. So if I copy from work and then I should be able to, yeah, rearrange things a little bit so it's more optimal. And we'll go ahead and jump in on 15 here. All right, so now we will notice that I made a mistake when I first set up my table of smallest primes, because the smallest prime of 15 is 3, not 5. I am actually good at math, I promise. So now we fix that problem, and we're gonna go ahead and try it again. Okay, so we've got a nice big number, 14. Let's inbox that, send out the 2, its smallest prime. Now we're gonna divide out by that 2. We should end up with a 7 in the count field if our loop is set up properly. Keep on going here. We got a 4, 5, 6, and now 7. Great. So now we're going to copy. We have a 0, so we can, that means our loop is working. So now we need to work on our actual continuation of the problem. So we do our divisor, we copy from our count to work, and then we can start the process again. So we'll put that there for the time being. And that should now work its way down. So we'll do it with 16 here. 16 comes in, so we should end up with 8 in the count. Just work through here. And we get a 6, keep on going, and 7, and 8. Okay, so 8 now goes to the work field. We jump up, and now we start again. So we're going to get the smallest prime of 8, which is 2, outbox it, and then start the loop again. So this will be good. It's working. But we can save a step there by skipping an additional copy. And we need to reset our count variable because it needs to restart for every loop. So okay, let's check it with 20. And because I moved the initialization of the count there, we ran into a little problem, so I just need to reinitialize count up at the top of the entry. So that'll be good. We'll go ahead and step through here. We've got 18, so 18 we would expect to get 9 as the divisor. Step through here. Or 9 is the count, excuse me. So we'll keep on stepping. Step, step, step. 5, 6, 7, 8, and 9. Okay, great. So now we're going to copy that 9 to the work, reset our counter, and start the process again. So the smallest prime of 9 is 3. So now we're going to divide that 9 by 3 until we get down to 0 in the work. And now we're done, technically. So we've got 2 times 3 times 3 is the prime factorization of 18, but our program doesn't yet know how to stop executing. So if we keep running here, we're gonna output a 1. I think. Let's see. Yeah, we output a 1, which is not what we want. So now we can work on our end case, and we need to figure out how we're going to tell the program that it's done. And it's going to get to a 1 eventually. It's going to copy a 1 from the work field eventually. So what I'm thinking is if we, not bump, we don't want to bump. So if we subtract 1 from work and it ends up being 0, that means we're done, so we can start again. And then if it's not 0, we'll add 1 back to it and start going. So this should now work. We'll get a 5 in, 5 becomes our divisor. We send out 5, get a 0, add 1 to the count, copy that to the work, reset, and now we'll get a 0 and we're done. So we'll start again. We'll reset our counter and away we go. So this seems to be working now. We'll just run through it for a couple more numbers. So far, so good. 7. Now we'll do it with 7, output the 7, get a 0, and we'll be done. Alright, how do we do? Okay, we did complete it. 72, and we did it in 237 steps, so I'm happy with that. It's definitely faster than our previous solution. It's not the fastest I've seen. I have seen some other solutions on YouTube using what is essentially a binary search tree, which basically it branches based on dividing the number in half, basically, and just searches for the prime factorization of the numbers as they are split up by 2. But I'm happy with this solution. I didn't just want to copy someone else's solution, I wanted to come up with my own. I did it in the speed challenge. And it does go to show that for some problems, if you have the space and the time to do a lot of pre-computation before the fact, it can greatly speed things up. So in this case, because we did have all the space in memory to compute the first 20 smallest prime factors, it sped up execution greatly once we got into the actual processing. And that's kind of similar to the concept that we talked about in an earlier video of dynamic programming, where the entire point is to save the solutions of smaller problems as you do them so that you don't have to recompute them. So in this case, we did a lot of the pre-computation beforehand so that we didn't have to compute everything over and over again like we did in our first iterative solution. So, I'm happy with my solution. 237 came in well under the 399 speed requirement. So let's just watch this one more time. We'll do our legwork ahead of time and then output. And it's possible that I have some inefficiencies in how I'm clearing the counter variable and how things are working here, but it would shave a couple of cycles off probably if I went back and fixed it. But anyway, I'm happy with my solution. So I will say this has been a Software Engineer Plays. Thank you very much for watching. If you enjoyed the content, please consider liking, subscribing, ringing the notification bell, and sharing with a friend. But for now, I hope you have a wonderful day. Go out there and solve some problems. Thanks. We'll see you in the next video.